Okay, ladies and gentlemen, we're going to go through the graphing and data tables part of the notes. What we're going to see is that as you go through graphs, you've got to decide a type of graph that you want to use. So we look at line graphs and bar graphs. Line graphs tend to show relationships between two variables, meaning that as one changes, so does the other. It's a gradual change. Often these are timelines type of graphs. A bar graph is used to show comparisons. These are typically like chunks of data. So a bar graph might be made out of data if you were to select or record the number of people who have Toyotas and the number of people who have Chevys and the number of people who have Fords. They're individual chunks of data to show comparisons. These are going to be separate bars that don't touch. So in your rules, you'll see dependent variables. Dependent variables are the variable that the scientist is measuring. It's plotted on the vertical axis or the y-axis. That's down here. This is the y-axis. All right. Now, rule number 2 about the independent variable. That's the horizontal axis. The independent variable is the variable that the scientist is in control of. So I can decide how often I collect my data. I can decide what it is that I'm measuring. That's the independent variable. All right, so rule number 3, the spacing on the axes. This can be really challenging, so I'm actually going to direct you down here. When you do the spacing for the scale, you do not have to start with 0 unless your data specifically shows 0 as a data point. So we have 0 as a data point in our data table, so we will have 0 on our graph. All right, the scale is represented by the space in between the lines on the graph. So in this case, from 0 to 4 and 4 to 8 is the same value. Each one has to be 4 as I go up the graph. You cannot change that. The scale has to be the same. The same rule applies down here for the x-axis. It doesn't have to be the same amount in between each line, but the value in between each line must stay the same, regardless of what your value is on the data table. So if I were to theoretically have a value on this axis that was 15, I wouldn't have to have a line that said 15. I would need to graph that in between the two lines. So your data in the x-axis doesn't have to fall on the line, but your values between the lines has to be consistent. You want to make sure you label each axis with the data from the data table. So in this case, we've got a title, and at the top of each one of the table columns, and that's the information that needs to be included on the labels for your graph itself. Now, one of the other stumbling blocks as you convert a data table into a graph is that you need to know which column goes on which axis. Now, I teach that it's alphabetical. The x-axis is always first and the y-axis is always second. So it's alphabetical, X, Y. Right? So the first column will always be the data that goes on the x-axis. The second column and any subsequent columns would be plotted using the y-axis. The IV, right? IV grows on the ground and the independent variable goes on the ground. Right? So what you're going to make sure is that first column goes on the horizontal axis and you label it properly. All right, so now once you've set up your scale, looking at the smallest value and the largest value, and you need to make sure you spread it out as far as you can. Right, so in this case, it makes a lot of sense for me to count by tens.